Okay, so let me briefly introduce our organization first. The AI Alignment Network, ALIGN, is a nonprofit organization based in Japan that aims to create ecosystem for researchers and practitioners in the field of AI alignment. And AI alignment here includes not only technical machine learning research, but covers broader topics regarding interaction between human and AI. And in this webinar series, we invite leading researchers and field builders in AI alignment, AI safety to share their insights and expertise so that we can stimulate discussions in Japan. But we also welcome participants from all over the world. So today we invite Dr. Evan Miyazono, CEO of Atlas Computing. He has a PhD in applied physics from Caltech, and he has led research at Protocol Labs, where he directed various coordination mechanisms for meta science and public goods funding, such as the one called HyperCerts. And in 2023, last year, he co-founded Atlas Computing, a non-profit organization developing AI tools with safety guarantees through the use of architecture based on formal methods. So in this webinar, we will hear from Evan about Atlas Computing's approach to reducing AI risk and what he has in his mind right now. So let's welcome Dr. Evan Miyazono. So when you're ready, please begin your presentation.
Horribly coordinated. I can do better. Oh, appreciate your patience. All right. So thank you all for coming. I am here talking about scoped safeguarded AI tools, and I'll start with a bit of motivation. I think that there are many things to be excited about or worried about when it comes to AI. And one thing that I feel has been generally underrepresented is this concern that today you might make a fairly simple request and get a simple response from your AI system. And you can then review that, determine whether or not it is what you want. But the goal of building increasingly capable AI that most people are pursuing, and the way they're pursuing it, means that soon you'll be making complex requests and receive very complex responses. And there isn't really any expectation, I think, that we will increase our ability to review if these things are what we want. And so this happens well before you start ending up with large-scale superintelligence type risks. This is something that you can imagine happening on a very short time scale related to generation of software or generation of small molecule synthesis pathways or things that people are trying to use AI for in commercial problems at scale today. And the way people demonstrate safety generally is by testing for risks under controlled conditions. I think that this is absolutely something that we should be continuing to do and is very good. But part of me looks at that and thinks that it looks very similar to testing a safety railing by pushing as hard against it as you possibly can. And I think that there's generally, well, as soon as you make this connection, it becomes very obvious to ask, is there a better way? What would be a better way to do this? And this is a very busy slide, but I will highlight that we think that AI agents should be built to not be these monolithic, inscrutable single systems, but instead they should create intermediate outputs that facilitate human review. And so instead of something where you're generating something that acts like an informal spec and an AI system generates a candidate solution, and then you hit a button and it becomes the approved solution, we should instead have something where you are, especially for maybe not for every AI output, but for places where you will want to review it and review isn't easily scalable, you should have a specification assistant that helps you use a language to generate a set of criteria for what failure would look like or what a bad outcome is. That gets used by a solution generation system that gets you a candidate solution accompanied with a proof that your solution satisfies this specification and does not hit one of these failure criteria. And then your lightweight solution checker can trivially give you a verification that the solution, or the proof is valid and the solution does in fact meet the spec. And so that's the brief high level problem we're trying to solve and how we're going about it. I know there was generally potentially interest in some other things I've done. My background has been kind of weird, so it feels worth tying the threads together. I will note that I am not an expert in any of the fields that I am going to be speaking about after the next slide. I have been at the cutting edge. My PhD was building solid state scalable optical quantum memories for optical quantum internet. After that, I decided that I wanted to have impact on shorter timescales, and I joined an incredibly, possibly the most ambitious startup of its day. And we ran an unconventional fundraise that was quite successful, that led to the need for a grants program. I built a grants program, and that included asking the question, what is the best possible grants program? And that has, you could imagine the answer to that being, it's more science that's better, faster, and cheaper. And faster and cheaper are pretty easy to quantify, but the question of what is more science or how do you quantify better starts asking some really interesting questions about how we evaluate and value public goods. And so at some point we generalized the tools that we were building and use the concepts from that to figure out what it would look like to build new coordination systems kind of from scratch. The venture studio was called Network Goods, and this is probably my favorite slide from the Network Goods era, which was this claim that humanity has a number of revolutionary coordination systems. Civilization advances by extending the number of important operations which we can perform without thinking about them. I think this is a really powerful idea that I love. You can imagine, you can look at any of these inventions and say, what was the world like before this one thing was invented? And think about what it must have been like to come up with that and put that into the world and maybe have some sense of how it would change things, but really see wide adoption and variations on that theme leading to impact that never would have been predicted and potentially was incredibly unintended and potentially even harmful secondary effects. And so we looked at these as inspiration and thought, what would it look like to build new revolutionary coordination systems where you can try to think more intentionally about the impact and the role these play in larger systems? And we ended up building 3 nonprofits, 2 for-profits, and an open source community around how it could be better to fund public goods and commons. So that's all I'm going to say about this, but I'm happy to answer questions about it later. One of the projects that came out of this venture studio was the open agency architecture, which I imagine some of you are familiar with. I like to point to this quality bar of, this is probably worth the reader's time, as my first contribution to the field of AI safety. Even though this is David Dalrymple's write-up, I think that this is pretty close to a direct quote of the instruction I gave, or the suggestion I gave, rather, of how he might think about increasing his impact by putting things into the world slightly sooner than he would otherwise feel comfortable. Many of you who, I imagine everyone who's familiar with this program knows that this is now the Safeguarded AI program at the UK's Advanced Research and Invention Agency, which is deploying 59 million British pounds to accelerate this. I'll be speaking a little bit more on this later, but I think that's probably a nice rounding off of who I am. And in terms of what Atlas Computing is doing, we're taking this architecture of we have increasing complexity of requests and increasing difficulty of review, and looking at what this means in very specific domains. Most of what I spend my time thinking about is not general intelligence risk. It's actually, what does it look like to address risks from AI in narrow regimes with, and I'll try and mention later what it could look like to stitch these together to create a general network, like a general net, safety net type thing to cover general intelligence risks. But the idea is that AI capabilities because action is harder than review, or sorry, action is easier than review, we should expect to see risks outpace benefits as disruption is facilitated faster than stabilization. And so you can look at the code generation. Easier to make viruses and exploits than it is to fix software vulnerabilities, partly because vulnerabilities are a socio-technical problem. It's probably easier to make new pathogens than it is to cure diseases at a systemic level. I expect that, at least in America, there will be legal loopholes that people will use to exploit laws in our highly litigious society here faster than AI can be used to patch legal ambiguities. And I think that there are, if you look at kind of any domain in society, look for where review is happening. And I think you'll be able to see some place where AI will let humans race ahead of review, and our review systems will grow increasingly overwhelmed. And another thing about this is that when you have this review, you might be inclined to try and find the best scalable proxies for what good is. And the challenge is that none of these review techniques work well if you try to set a proxy. Goodhart's law states that any metric, when used as a target, ceases to be a good metric. And I think that this gets incredibly scary if you imagine people using profit as proxy for, is this agent doing what I want? This becomes runaway capitalism of kind of the scariest flavor. And so the solution that we're pursuing is analogous to that of the open agency architecture or safeguarded AI. Don't try to wholly encode the thing that you're optimizing for. Don't aim for alignment. Try and see if you can solve a simpler version where you just say, don't do these things. Here are constraints. If you do that, you can make tools to set rules that you force AI to prove that its outputs obey. You can do this, again, in various domains. We think of this as having steps about raising awareness of risks, generating specification language, and then making tools to use that specification language to validate outputs. And we're starting off with cybersecurity and biosecurity generally, because it seems like those risks and opportunity spaces seem the closest term. You saw this slide previously, but I want to go through and explain what this means for the specific example of software generation and small molecule design. So on the software generation side, you could imagine using an existing specification language like Coq or Daphne or Lean, and say having a user who wants to upgrade some Fortran code or some C code, and you send that into an AI-based specification generator. And I'll acknowledge here that this and many other problems that I highlight as like, this is one box in a series of 4 boxes. This is a holy grail problem for an entire subfield of computer science. The next slide has holy grail problems for the subfield of biology. But if you're talking about if you're building this system in the face of extrapolative growing AI capabilities, or next to someone who's building general intelligence and trying to solve general intelligence, I claim that while this is still ambitious, you should view it as far more feasible than it might be in the context of a single university grant. I think that this has to be a larger effort, but it could be a large-scale government research facility effort, or something like the Human Genome Project, where a number of individuals come together and it becomes Or I guess another example would be the International Space Station, where you have a number of countries all participating, coming together, building something that no one of them would build, but is clearly beneficial to all of them. And now you start to see the public goods funding governance mechanisms start to come back into why I am working on this problem. So anyway, you take a piece of Fortran code, send it into a specification generator, and the specification generator gives you a specification in Lean for what that code is supposed to be doing. You verify this, review this, and maybe you send this, if approved, to a solution generator, which generates you a program and a proof that the generated program meets the spec, and then you can check that. And so you might ask the question, well, what does it matter if I'm reviewing a spec or reviewing code? And I think all of you who have generated code before recognize that sometimes there's a very important property, like I need this array indexing to not try to go outside the bounds of allocated memory, or I need these numbers to never go above 0, or this sum always needs to remain 100. That is something where you can you can probably add something to many places in the code that would change whether or not that's true. But that could be one line in the specification that you can look at, say, is this encoding what I actually care about in this program? And if so, has this been proven to hold true using the mathematical rigor of formal methods? And if so, that aspect of your review is now solved. You don't have to understand the entire code base. You can just see that, and this rest of this system is trustworthy relative to any other way you could validate this software. I realize I've kind of just jumped into formal methods, assuming that the notion that you can generate mathematical proofs about the properties of states or outputs of software. I realize this may not be something everyone has come across, and I'd be happy to answer more. I will also note that is as deep as I'm going into this. So happy to recap, answer questions in the Q&A portion. For the biochemistry example, the first step is really to do this green box, where I want a competition that will set different participants against each other in their ability to generate an analog to AlphaFold, where you get a small molecule, and what you get out of this is a set of every predicted interaction with every metabolic pathway that we know of. And then the question becomes, can you have a second AI system that will, from this information, generate you an LD50 or some other measure of toxicity to tell you how much you should be worried about this molecule being inside a person? Once you have this competition running, I think it becomes an easy Schelling point for the community to come around and say, let's use this as use this competition, this time, this place as an opportunity to improve our understanding of what toxicity means and how we predict it and how we understand the interplay of different components. There is massive amounts of novel science here. But once you have this, I think it becomes a very compelling tool, because if you as a user want to use natural language to say, design me a drug that will modify this pathway, will modify some part of a metabolic path cycle, but do so without causing harmful effects, then it's very valuable to have a tool that will let you formalize, quantify objectively what you mean by modify and what you mean by harmful. And I think that this kind of framing around different types of interaction is the right way to objectively state your subjective preferences about what toxicity means. And then you could have a solution generator that would go through and use in vitro, in vivo, in silico testing to verify that a molecule does in fact have the properties you want. But you could do this in a much more scalable, much more automatable, and hopefully much more efficient way. and have the kinds of guarantees that we've come to expect from different aspects of engineered systems in society. One nice thing about this goal of let's set constraints around what we don't want, as opposed to try to encode what optima we are maximizing, is that specifications are very compatible with governance processes. This idea of specifications is consistent with the way we set international treaties and national laws and local laws and maybe even personal goals or requirements. All of these things have to stack and compose. If you were setting optima at these various levels, the resulting optima after you try to compose those becomes either highly non-trivial to compute, or you have the ability where one optima function can undo or counteract the effect of the constraints of a different one. And this is not the kind of thing we want when we're talking about catastrophic safety or safety against catastrophic risks. I have the long-term goal that it would be great to have an international standards organization of verifiably governable AI where different organizations all help onboard, build tools, and maintain some high quality standard for what it means to have specifications. You might ask why Atlas Computing is a nonprofit. I very much run Atlas as we are a nonprofit that runs a lot like a for-profit startup. And the reason we're a nonprofit is that I think this architecture is the best way to govern AI. And if I'm right, then this should not be a competitive advantage. This is something that everyone should have access to. And if we spin out a for-profit company, then I want to have a governance requirement that I or whoever replaces me has to onboard a competitor to this architecture the very next day. Because I think that this is really only safe if you can really only achieve safety if everyone uses the best safety tools out there. I've been talking mostly about what I've been doing and how we are approaching this very narrow field by field approach, but it's really important to note that this is part of a much broader category called guaranteed safe AI. That general architecture is that AI systems should have an auditable world model to simulate the impact of proposed actions, that you can specify states of that model that will let you say what safety is or what states aren't safe, and some kind of verifier that validates proposals against the specification. If this sounds completely unfamiliar, I would point you to this paper with a bunch of very significant, well-known authors, and it does a great job presenting what this could look like as a general architecture. I think I will definitely share the link to these slides in the chat afterward. I'm not sure. I usually have a QR code at the end that is a link to the deck. I may not have that in this deck. Here's also a link to davidad's specific program, which falls under the umbrella of guaranteed safe AI, but this is a more specific construction that fits within that category. And one of the things that I did with Davidad when I worked with him at Protocol Labs was I would frequently work on simplifying things that he was thinking about down to the point where they were easier to implement, easier for users to understand. While I very much enjoy this document, it has diagrams like this. And I like to take diagrams like this and turn it into this, where the color scheme matches perfectly. There are far fewer boxes, but you get this general impression that stakeholders are contributing theories or requirements using AI tools to a specification generator or something like a GitHub for multiphysics simulation. That goes into a proof generator and solution generator that can be passed on to a proof checker. And this workflow, when you go back and now look at this, you can see the parts of, okay, individual users providing specifications or theories to some kind of GitHub for multiphysics, and then a solution and proof generator that passes a solution and a proof certificate out. Hopefully this is helpful in thinking about what Davidad is trying to build. I also like to annotate this with a highly reductive, oversimplified 1.1 is a composable modeling language that looks like a domain-specific language plus Git plus CI for scientific theories, and then build a working implementation of that. And then AI-accelerated modeling and proof generation and certifiable AI in case your outputs are themselves machine learning models. 1.3 here is a user interface, and then these are the same way that I was talking about deploying tools for narrow domains, these are also tools for narrow domains, but they are, when Davidad says he is going to talk about epidemiology or metagenomics, you might ask, what's the difference between this and what Evan's proposing? What I'm proposing is very narrowly scoped without the kind of scaffolding where it could expand horizontally to also include something like strategic R&D planning, where in Davidad's construction, these are adjacent only initially, and they could eventually be combined through some significant number of contributions to various scientific theories in this version-controlled system. So nothing that I am building, I expect will link together in the immediate term. But if you think of what I'm doing as solving UX and customer acquisition for safeguarded AI, then you could really easily imagine me one day saying, dear users, that version 2.5 tool that you've been using of ours, we're going to replace it with version 3.0 of safeguarded AI. It can do everything that your existing system can do, and it can do all these other things too. So you can imagine why it's very useful when this research program concludes to have done that kind of implementation, because the number of users who are using that and can be impacted by the breakthroughs of safeguarded AI, I think, should be grown independently of the research itself. So I think this is all working up to a general claim that using a model, using verification of simulated behavior can potentially sidestep alignment. You can have provable safety properties, even extracting useful work from a presumed misaligned AI without needing to trust or embed all of your values or have some way to make sure you're democratically eliciting multiple people's values. I realize that I'm close to or roughly at time, but I wanted to give two quick hot takes about meta-science because I think I like thinking about the science of science or applying a scientific perspective to science as a system. And these are two very, very underdeveloped ideas, but I present them as things that might be interesting to think about. The first one is this notion of the open versus closed world assumption. In formal logic, you can think about how you are representing knowledge in a database. And the closed world assumption is basically saying that if it isn't stated, it's assumed to be false. If you think of this in the context of a knowledge graph or a relational database, there are very easy examples where, like, if you don't have the has a child edge, or like if there is no entry has child name, then you assume the person has no children, kind of thing. You can see obvious benefits to this in that it becomes much more terse, but also challenges in this, in that it implicitly assumes a lot of things. The open world assumption is the opposite and says that some unstated things might be true or might not be true. I've come back to this because it's a close but not perfect metaphor for a few different things I've seen before. One of them being, let's watermark all the AI content. This feels like a closed world assumption because you're saying that if there's no watermark, then it was generated by humans. There are things on the open world side that are a metaphor of, this example is WordSig, where Andrew Critch proposed using QR codes and public key infrastructure to sign notes associated with videos so you know that video isn't deepfaked. C2PA is a content standard where your hardware has a secure enclave that with a private key that signs images taken by the CCD of that phone or camera, and you can use this to track provenance. I think things like this are very much the complement to this watermarking approach. Similarly, you could imagine the closed world versus open world assumption looking like, do you isolate the source of risk versus isolate the risky objects, define what risk is and protect those directly? And I think that this kind of matches a little bit onto alignment. And again, this guaranteed safe AI notion where you're identifying types of risk, you're evaluating whether or not proposals would be risky and putting them into the world. Not a perfect match, but still, I think something interesting to think about and something interesting to look for in other problems. The second hot take that I wanted to give was first to plug this particular post. If you want a sense of where alignment and AI safety is as a field, I think that this is a fantastic starting point. This is their taxonomy. And I will note that we are in this taxonomy as a theoretical galaxy-brained end-to-end solution, which I have previously found very amusing and a little bit frustrating. I have yet to comment on and attempt to change or improve this, but it's I think it's very interesting to compare these various approaches to not just what a technical solution could look like. I think one slide I almost made that I didn't end up making was this idea that most important problems are socio-technical problems. If you haven't come across the term before, I would recommend the term wicked problem. There's a great paper on it from, I think, the 1970s or so, wicked, W-I-C-K-E-D problem. And the idea is that there are some problems that are virtually impossible to solve, partly because they're just impossible to state what solved would look like. And I think that AI alignment might fall into that category safely, and that you can easily come up with a definition of alignment that is unachievable based on like human consensus building. But there's this thought process that we have socio-technical problems. A lot of AI safety approaches, I think, are technical solutions. A lot of governance solution directions, I think, are social solutions. And what I think is most likely to succeed is either something that looks like a socio-technical solution to the socio-technical problem, or it looks like a social solution that interfaces well with the technical side, or a technical solution that interfaces well with the social side. And so I tried to find a way to make this point without making it seem like I am just plugging what we're doing. But I do think that there's something fundamentally motivating about the fact that if you look at how liability works in the real world, this is an example text from a bill that may or may not pass in the California state legislature over here. But the idea is that this is a law saying that before initiating training of a model, you have to implement a safety and security protocol that provides reasonable assurances that these bad things won't happen. This is roughly how building codes work, or fire safety codes, or like registration of electronics devices and like you have a regulatory body that guarantees that batteries will not explode in your devices. And if they do, there's a recall. We have systems that work fairly well, even in the case of potential catastrophic outcomes. I don't think a lot of financial tools work well in the case of catastrophic outcomes. If you disagree with me, then I will happily sell you some insurance that pays out if money stops working. But I feel like the traditional approaches to checking how liability, or to verifying liability, look again like this pushing against safety railing to show that it works. And so I think if I were going to make a hypothesis, it would be maybe it's not guaranteed safe AI, but I think maybe it's not even formal verification or something that's asymmetrically defensive or asymmetrically risk reducing. But I think the system, the tools, the solutions to AI risk that get adopted are going to be the things that match the closest to existing social structures and the social side of socio-technical problems. Briefly, our like very concrete goals are to identify projects and actually start building tools for people to start using AI to scale deployment of formal methods. We're growing the team. We're going to try and launch that competition I mentioned about biology. There is a small chance that I did not update that QR code. So if I didn't, then please note it in the chat. Otherwise, I'm happy to chat. You can catch me online. If you know of potential users, people who operate critical systems that want to use formal verification to upgrade them, I'm thinking like water, sewer, hospital, electrical power line, like power plant companies, things like that. I think those would be very useful or interesting. And if you go to our blog, the very first blog post has, I think, 7 different ways to kind of keep tabs on what we're doing generally. But other than that, I'm happy to answer any questions that you might have.
Okay, thank you so much, Evan, for such a wonderful talk. We learned a lot, not only about your Atlas Computing's initiative, but also like broader scope of what is going on in AI safety. And I personally appreciated your simplified version of the ARIA davidad project. So I think we can take some questions. So please feel free to raise your hands.
And while people are thinking about it or writing, I'll note that I would like to argue that Filecoin proof of replication, paper certs, an internal project that we never really released, and now Safeguarded AI are all 4 projects where davidad started proposing them and started building out the formalization. And I took it upon myself to build teams around implementing scoped, more easily understandable, more short-term versions so that they can usher in the longer-term change. So this is something, the like Evan builds dumbed down version of davidad's figure is something that I can try to claim many years of experience doing. Any questions?
May I ask a question?
Oh, yeah.
So this is not a question particularly to your initiative, but I have a question on the applicability of this guaranteed safe AI. And you mentioned you'll be doing this in piecewise, like you'll be dealing with cybersecurity first, and then biosecurity, and then move on to social and legal systems.
Yeah, I wouldn't expect to solve any one of them before moving on to the next one. I think these are all like wicked problems. I think my hope would be to set up a stable team that's well-resourced on a good trajectory, and then transfer my focus onto starting new directions. But my hope would be to have, in the same way that you could imagine a large-scale law firm that has teams specializing in a bunch of different tools generating, like many large teams specializing in different parts of the law, describing what good behavior is in different parts of society, or the way a government might have committees. We might have similar kind of structure, focusing on different things, with probably also a team that specializes on the interstitial bits.
Okay, so I agree that solving even one of those domain is huge work and spectacular achievement. So I think Manuel is raising your hand, so please.
Right. Well, thanks, Evan. So in your talk, you actually went through a few different, I guess, examples or fields where we might encounter like similar problems to the one we are facing now when looking at, say, complex and possibly unsafe AI. So I'd like to ask you if you have So if you had to pick a specific case where, so what is the closest thing, what is the closest example in a different field that would actually capture the whole proposal or most of the parts of the proposal of a safeguarded AI? As in, like, we are not even interested in considering things that are going to potentially be unsafe. Or what is the I don't know, the example where the most constraints have been imposed so that we never reach like certain outcomes?
Would it be fair to summarize that as, can I describe the most long-term general intelligence and how one might use safeguarded AI as an architecture to minimize risks from that intelligence? Is it about the generality, or is it about the specific, like the yeah?
So it's more about like a field, say, I don't know, if we are trying to build like safe airplanes, then we might have a specific legislation that imposes constraints on engineers that have to do particular things, that we might have, I don't know, material that are only allowed for, this particular part of an airplane, but not for this other one. And we might have like further constraints that come from.
Arguably, if you're having an AI system generate an airplane and you're using safeguarded AI, then you have encoded a like structural mechanics, statics dynamics, computational fluid dynamics, combustion, all of that into one simulation system. You could probably say, like, this plane should not, like, the velocity relative to the ground, or the velocity perpendicular to the ground, should never be higher than this. The only thing that should touch the ground is is the landing gear, and the internal of the plane should remain pressurized and at roughly this temperature. Is there any set of inputs for wind turbulence or fuel fuel contaminants or anything like that, or even if you wanted to include it, changes to the internal distribution of mass that would result in any of those statements about the plane to no longer be true? I think that the more theories you have to include in your multi-physics simulation, the harder this becomes, the longer you might have to wait to get your proof that this is safe. If you want something that is very specific, you could imagine a system that says, these are assumptions about the bounds of air turbulence that a plane could possibly encounter. This is our model of how the control system modifies the flight control surfaces. This is our model of how the control surfaces affect things like the orientation of the plane. Let's prove that this autopilot module, software module, never results in the plane being upside down. And this seems entirely reductive, and this does not seem like it is at all an improvement over what we do today, because it's literally what we do today. Formal methods are used to show that there is no set of possible wind, temperature, turbulence conditions that would lead to a plane reaching certain prohibited states. And that is a thing people use formal methods for now. So improving the model, improving more types of physics that you're simulating in this system feels like it's increasing in difficulty, increasing in impact, hopefully improves your ability to leverage generative AI for things like design.
Okay. So, Uesaka-san is raising her hand, please.
Yeah, thank you so much for the talk. I'm sorry I cannot turn on the camera. So my question is, I would like to ask the scope of the formal proof that can be applied on. So I imagine like domains like web applications, or maybe if the outcome is like a neural network, it's pretty difficult to create a formal proof. But would you think it's like a matter of time that these like domains can also be applied using formal proof, or are a lot of the domains like in principle cannot be proven by the formal proof? And like finally, like so what percentage of all the use cases that people currently use the generative AI for can be like proven using the formal proof, maybe let's say in the future?
Okay, so to the, like, can you formally prove a machine learning system? I think that's area 2-3 of Davidad's program. My understanding is right now, like mostly when people talk about formally verifying an AI system, they're doing some kind of ball continuity between input and outputs in the embedding space. I don't think that the embedding space maps well onto what we actually care about in terms of safety or risk. And so I don't think that that's, I don't think that this is something that is easy to make useful for users now. I do think that it is something that is very plausible. I'm forgetting, I was speaking to someone recently who had some really interesting, there's like a slide deck or something that I'll try and share over email or something as a follow-up, if I can find it. But there is interesting work being done around trying to prove things about transformer models or things like that. And so while I am not following it closely, I don't think I'm writing any of it off. And it's definitely something that Davidad is interested in because he hopes safeguarded AI systems will be able to output things like language models and prove properties about the behavior of those language models. When I talk about proving the outputs of AI, I'm mostly thinking about things like code or small molecule design for now. But there are things that you can think of in terms of use cases. I mean, generally, I will say that trying to specify the safety of an idea or of an image is probably it feels like if you can do that, you can specify the safety of anything else because anything can be reduced to a language description of the thing. And so like language and ideas feels like the hardest one. That said, there are certain things you can formalize very easily, even without going into trying to formalize the language model itself. Great example I will give is if you try to prompt engineer an LLM to not output any 5-letter words, that is incredibly challenging / an open research question, possibly impossible. If you make progress on that, I would love to know. But based on how tokenization works, I think it's just very hard to do. That said, I think any undergraduate student at the end of a formal verification class should be able to write a wrapper that calls an LLM and can be formally verified to never output a 5-letter word. You just trivially delete them. Like you can prove that if you can define what it means to be a 5-letter word, you can just remove those. And it's very easy to prove this. That sounds like a totally toy example, but in the US, we have the idea of protected categories for job discrimination. And if you can express what it means to have an indicator word that expresses you are a member of that category, then you could build a wrapper around a resume classifier. Resume classifier can be as biased as you want, but if you take any resume as input and send it through one time for every single possible combination with keywords toggling on or off that group membership, then you could imagine taking all of those scores, averaging it, and it's trivial to show that the averaged output is insensitive to whether or not your initial resume had keywords that implied membership in any one of those groups. And so this is an example of a system where we have a legal system that has, in the US, we have a legal system that has specified you can't have your answer be different based on any of these conditions. These subjective conditions are encoded objectively in these words and maybe other words. And if you change these words, then you can see this output. And the nice thing about this is that you can easily take this tool, open source it, and say, look, this is our intent. We've tried to make it the best thing possible. If you believe you've been discriminated against because of because of some gap in what words we were listing and like in using to invert membership, and used a different one, you can check and see if your membership was included, and we'll fix it. We will we'll run your resume through again. And this becomes a system where it's not a group of AI users who have delegated review onto an automated system and they're just letting it run. Instead, this is now a system with a feedback loop. This is one narrow system. You asked about kind of, I think it was the fraction or the number of current use cases that you could formalize. And I don't have a good way of quantifying that. I think my intuition says far more than the number of things that we're doing. And I think the lowest hanging fruit is the system where a specification language already exists, namely software. So I'm focused on software generation. I do think this expands beyond software generation. I think that they're like, in terms of like explicit imagery generation, for instance, there's a famous US Supreme Court case where the Chief Justice of the Supreme Court was quoted as saying, "I know it when I see it," in response to a category of explicit images. And like, that was as close as America has come to specifying what it means to be an explicit image. It's not a great system. That said, there are other things like gerrymandering or the politically driven modification of voting districts, where people have reached for mechanisms to quantify and to measure and quantify what it would mean for this to be a perceived violation of people's voting rights. And if like the way they achieve this is they pick a metric, they design a metric that seems reasonable, and then they deliberate a few free parameters within that metric. So if you're above or below a particular threshold, then this triggers. And that seems like the kind of thing that you can formalize very well. I don't think that specification languages or specifications should be generated by a bunch of computer programmers or formal methods people. I think that this should probably have policymakers in the loop. It should probably have subject matter experts in whatever system you're looking at. It should have stakeholders from all the various groups. I think collective intelligence and democracy play a very important role in all of these. If you're interested, I could try and convince one of the founders of the Collective Intelligence Project to give one of these seminars and maybe talk about that. But yeah, definitely wish I believed there existed an easy answer for that question. But I think that it's a problem that's going to be solved in a lot of very small pieces.
Yeah, thank you.
So in that sense, the formal methods alone does not solve the problem. So you have to engage with people and decide which specification is adequate. So
yes, and it's worth noting that with alignment, you really should be doing that too. I think alignment tends to treat this as this is what I was getting into with alignment treats this as a technical problem. Formal methods has a nice interface. It's a technical solution with a nice interface to a social solution or existing social systems with aligned, like there's a fun thought experiment. If you're like, I think that I think humanity will solve the alignment problem in 5 years. Imagine that we build a system, like we have an algorithm where like you're just like doing conversation between a human and a language model, and it takes 80 hours. But once you've achieved 80 hours of conversation, you can say with reasonable safety for a specific definition that language model or that AGI system is now aligned with that human. How do you build an institution or a process by which you, as not a person who, like, as someone who may not necessarily be involved in this process, will believe this is legitimate, represents you well? Like, this is a fundamental question of democracy, where I mean, designing these systems becomes an implementation of John Rawls's original position thought experiment. This was like a political philosophy, like, how do you design a just society? Well, you put a bunch of people in a room and you put them behind a veil of ignorance, and you're basically like, you tell them, design the society, and then we're going to roll dice, and we will put you randomly into a role in the society. And it's a really great idea. It also has some very clear flaws, but it's weird if we talk about a singularity beyond which it doesn't make sense to forecast where you will be in the society. Very much creates this veil of ignorance where we're all here trying to design and make proposals about and nudge civilization in a direction towards an architecture for society where we have no idea where we'll be in it. And I think it feels like defecting from one's humanity almost to try to say it's going to be okay because I'm going to be in charge. I'm going to take enough power for myself now that I can continue. I have reasonable reason to believe I will continue to have power into the future. I think that if everyone actually believed we're building the society, we don't know where it's going to be, that it could end up being a much more fair system that we get out of this.
Yeah, I think that was what you meant by like social solution interfaces with technical solution. So that you're building technical solution, but it has to be interfaced with social solutions. So can I make one more last question?
Absolutely.
Okay, so so you mentioned that this is a very big project, a very ambitious project. Maybe that has to be done like a human genome project. And related to that, many top AI scientists are stepping into this guaranteed safe AI approach. And so how do you encourage young researchers interested in AI safety to get into this field? Like, should they join a nonprofit like yours, or what kind of career paths should they choose, and in what timeline? Like, so what are your thoughts on that?
I do wish that I had enough funding. I wish there were enough funding in nonprofits right now to hire all of the ambitious and interested researchers who want to work on alignment. I think I'm enough of a capitalist that I believe that there are good business models here. And one of my big goals of creating the nonprofit is to create the opportunity space for other businesses to go and pursue things in a more scalable way. I guess a very concrete direction is that in probably like within a month, we're going to post a list of projects that we think are like roughly we're going from we're going from legacy software to auto-formalized software with proven program synthesis. I think we're currently sitting at around 15 different tools that would be used by humans in the loop to upgrade software in this way. And once we have this list up, I'd be very interested to see people start hacking on this and like labeling where they sit. And like, I expect we'll create a GitHub repository. And if you're working on a thing, then submit a pull request and we'll link to you, and we'll see how many of these tools we can build from like a purely volunteer-driven framework. I do expect that if this tool chain worked well and worked for a given source and destination language that a customer cared about, that they would pay for this and that there could be a business around this. I think that would be very compelling. I think there's definitely some amount of a lot of different potential directions. I wouldn't be surprised if going to work at AI safety institutes for people who are very interested in safety might not be a good or one of the best options, especially if you think that this is an interesting approach, because I haven't seen a lot of interest from within. I haven't seen a lot of people at AI safety institutes who are already bought into this as an architecture. And I think this could be really interesting. I do think that there's some amount of I think there's definitely a selection bias where people who are very interested in safety tend to have a narrow set of skills and want to work on a narrow set of work in a narrow subset of the roles involved in making AI risk lower. And it is quite possible that your skill set of understanding the problem, being quite technical, could be very well leveraged in one of these other types of roles. Maybe something looks more like a policy or a think tank or a startup founder or a nonprofit founder type role. These are things that you might not think about. But if I would, on the last slide, I had my Calendly link, and there aren't a lot of times that are reasonably scheduled in local time in Japan. But if you'd like to do a 30-minute consult on like, I really want to work on this, these are the types of things I care about, these are my skills, please help, then I would be more than happy to speak for 30 minutes, try and provide some direction and advice. And I think there's definitely lots of opportunities, and I hope to be a driver of an increase in the number of opportunities in this general direction. So if none of those seemed that compelling, if you're committed to a research project for another 2 years, but then after that, then please feel free to reach out about like whenever that makes sense. I'm pretty easy.
Thank you. I think we would like to spread the word that these kind of approaches exist in Japan, so that someone can interested can enter this field. So I think Yamakawa-san has been raising your hand. So if there's time for the last question, please.
So thank you for your good presentation. And I have one question about, because I'm a researcher about brain-inspired AGI field. So now we are building AGI like a human, and very specific, maybe we are more than not development, more making the specification like human brain. So your framework could be maybe a good way to our specification to more safer to human. And so I'm thinking about the possibility about how can we combine our brain-inspired AGI specification to the display markers. How can do you have some idea of, of thinking about that kind of thing?
The wisest part of my brain is telling me that you should speak to davidad about this. He has early in his career, he actually worked in neuroscience and started off in connectome mapping. And I would be surprised if he hasn't thought about what this could look, what it could look like to verify properties of an emulated brain. I, on the other hand, have not thought about this. It sounds well outside the realm of what is possible with the tools that I have at my disposal. But I think davidad might have thought very deeply about things in the near, like that may exist in the near future and how they could interact with each other. And honestly, I think that trying to connect to him on Twitter might be best method.
That's very nice.
Failing that, you can always send me an email and I can pass that along.
Yes,
but yeah, I think he'd be very interested in getting more on this. Thank you for the question.
Okay, thank you. So thank you for staying late, and I really appreciate Evan for coming and sharing his great talk. So please, everyone, give him applause, if possible. So yeah, I want to stay in touch with you. So I best wish you the best luck for your organization, and yeah, we'll keep up our effort also. So thank you very much.
Glad to hear it. Thank you so much for having me. It was a pleasure.
Thank you. Thank you very much.